Welcome dear students towards the lecture number 3 of the chapter classification of elements and periodicity in properties. In the previous video lecture we discussed in detail the Mendeleev's periodic law and the Mendeleev's periodic table. Now this lecture is about the modern periodic table. Dear students, in 1869 Mendeleev's periodic table was presented and Mendeleev classified 63 known elements of his time. Then in 1897, the first subatomic particle was discovered, which was electron. It means at the time of Mendeleev, there was no idea of the internal structure of the atom. There was no concept of the subatomic particles. The first subatomic particle was discovered by J.J. Thomson in 1897, and that was electron. And then a new term was introduced, which was atomic number. At that time, the atomic number was defined as the number of electrons in an atom. So, the number of electrons in an atom, that was referred as atomic number with symbol Z. Now, this symbol Z is from a German word ZAHL, which means number. Now, there was a new concept, that was the atomic number, but as the proton was not discovered yet, so atomic number was not defined in terms of the number of protons, rather it was defined in terms of the number of electrons. Then dear students, in 1911, the nucleus was discovered by the Rutherford. In 1913, Mosley studied the X-rays of the different elements and he presented the Mosley's law, according to which the square root of the frequency of the X-rays is directly related to the atomic number of the element which produces those X-rays. A and B both are constants. A is proportionality constant, B is screening constant. So if these two are constants, it means that the square root of the frequency and atomic number, they have direct relation with each other. And when a graph is plotted between atomic number Z and square root of the frequency, we get a straight line, and we do not obtain a straight line when the graph is plotted between atomic mass and square root of the frequency. It means that the frequency of the X-rays, that does not depend on the atomic mass of the element producing those X-rays, rather it depends on the atomic number of that element which produces X-rays. It means atomic mass is not the fundamental property, rather atomic number is the fundamental property which decides the electronic configuration and also the physical and chemical properties of the elements and their compounds. So there was need to modify the Mendeleev's periodic law and present a new periodic law based on the atomic number rather than atomic mass. That's why then modern periodic law was presented by Mosley, and the statement of the modern periodic law is physical and chemical properties of elements and their compounds are the periodic function of their atomic number. What does it mean? It simply means that atomic number is the fundamental property of any element which decides its electronic configuration, and it also decides the physical and chemical properties of that element and its compounds. And when we arrange the elements on the basis of their atomic number, then the repetition of the physical and chemical properties takes place after regular intervals. Then we see the periodicity, the repetition in the properties of the elements and their compounds. So instead of arranging the elements on the basis of their atomic mass, now Mosley says that the atomic number is the fundamental property and the elements must be arranged according to their atomic number rather than their atomic masses. And then the Mendeleev's periodic table was modified to the modern periodic table. My dear students, we know that periodic table is basically the tabular form in which elements are arranged according to their properties. The first periodic table was presented by Mendeleev, who is also called as the father of the modern periodic table. Now, the Mendeleev's periodic table was converted to the modern periodic table, but keep in mind that modern periodic table is not something new, it is not an innovation. Rather, the modern periodic table is just an improved form of the Mendeleev's periodic table. Now in modern periodic table, we have vertical columns which are called as groups or families. In the old system, there was a way to number these groups from 1A to 7A, 1B to 8B, and 0 group was used for the noble gases. But then, according to the recent recommendations of the International Union of Pure and Applied Chemistry, now the groups are numbered from 1 to 18. Similarly, there are horizontal rows in the periodic table, and these horizontal rows are called as periods, and there are 7 horizontal rows in the periodic table. There are 7 periods in the periodic table starting from 1 to 7. The group number is basically the number of valence electrons in that group. Group number shows the number of valence electrons in the members of that group, and period number, that is related to the number of occupied shells in an element. So the period number shows the number of occupied shells, and the period number is basically related to one of the quantum numbers, that is the principal quantum number. Now let us look into the periodic table, what the modern periodic table is, and let's have a detailed look of the modern periodic table. So this one is the modern periodic table in front of you. This periodic table has some horizontal rows which are called as the periods, and there are vertical columns which are called as the groups. Now my dear students, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 and 18. These 18 are the vertical columns and they will be called as the groups. And in the similar way, 1, 2, 3, 4, 5, 6 and 7. This one is the 7 horizontal rows and they are called as the periods. Now the group number is related to the number of valence electrons, or it is related to the valence electronic configuration of the elements in that group. So if we see this group 1, now all the elements in this group 1, they will be having the same valence shell electronic configuration and they will be having 1 electron in their outermost shell. These are alkali metals: lithium, sodium, potassium, rubidium, cesium and francium, and hydrogen is placed on the top of the group 1 just to show that it also has same valence electronic configuration as that of the alkali metals. It also has 1 electron in its valence shell. In the same way, this group is the alkaline earth metals. Then the third A group, that is the boron group or boron family. Now this one is the carbon family, nitrogen family, oxygen family. 7A, a very famous group, these are the halogens. And 8A, this group is now in the modern periodic table group 18, that is about the noble gases. And similarly, this one is the middle portion, and they are all called as the transition elements or transition metals, while the elements in group A category, 1A, 2A, and then 3A, 4A, 5A, 6A, 7A, 8A, these are the typical or representative elements. While the elements in this portion of the periodic table, they are basically the transition elements or transition metals, and in the old version, they were called as the B groups, and these typical elements were called as the A groups. But in the recent recommendations of the IUPAC, now all the groups are numbered from 1 to 18 and the noble gases are present in the 18th group. And similarly, dear students, this one is the bottom of the modern periodic table, and at the bottom of the modern periodic table, there are two series having 14 elements in one series, and these two series, they are called as lanthanide series and actinide series. They basically belong to the transition metals, but lanthanides are called as lanthanides because they exist after lanthanum, and actinides are called as actinide because they are present after actinum in the periodic table. Now, my dear students, this one is an overview of the periodic table. Most of the elements of the periodic table, they are metals. Like these are all metals. This middle portion, they are all metals. And similarly, these are also metals. But you can see this portion of the periodic table. Now, my dear students, this portion of the periodic table, that consists of the metalloids. Metalloids mean these are the elements that have intermediate properties of the metals and non-metals. So this was about the groups. Now, what is about the period? The first period is called as the shortest period because it has only two elements. One is the hydrogen and second one here, that is the helium. So the first period is the shortest period with two elements only. Now, my dear students, the period number 2, this one is the period number 2. This period number 2 has total of the 8 elements in it. That is called as the short period. First one is the shortest, second is the short period. Similarly, the third period, it again has 1, 2, 3, 4, 5, 6, 7, 8. 8 elements. That is also called as the short period of the periodic table. In the same way, the third period that has 18 elements 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. And that is called as the long period of the periodic table. In the same way, this fifth one, it also has 18 elements, that is the long period. And this sixth period, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. These are the 18 elements, and this lengthenide series is also part of the sixth period. So there are 14 elements here starting from lengthenum to this one, and the 14 these and 18 these. There will be total of 32 elements in the sixth period of the periodic table, and that will be called as the longest period of the periodic table. While the seventh period, it starts from Francium and it has now these elements. And my dear students, the seventh period is nowadays that is called as the incomplete period, and all the new discoveries of the elements, that will be the part of the seventh period. Now this period number actually shows the number of occupied shells in the elements of that period. If we have period number 1, it means there will be only one occupied shell in hydrogen and helium, who are the members of the period 1. Similarly, in period 2, the 8 elements will be having 2 occupied shells, mean there will be electrons in the first shell and their second shell will be the valence shell. Similarly, in period number 3, the valence electrons will be present in the third shell, their valence shell will be the third shell. In period number 4, total occupied shells will be 4. In period number 5, total occupied shells will be 5. And similarly, in 6 1, total occupied, they will be the 6 shells. So period number is related to the principal quantum number. It tells you that how many shells are filled with the electrons in an element. And the group number, that shows the valence shell, number of valence shell electrons, or you can say it shows the valence shell electronic configuration. In the group number 1, all the alkali metals, they have only one electron in their outermost shell. They have a configuration of ns1. And my dear students, on the extreme left, in the middle of the periodic table, on the bottom of the periodic table, these are all metals. While the right side of the periodic table, this one, that contains most of the non-metals or some of the metalloids. Just like these are the steps in the periodic table, and they have metalloids in them. And this group 8, which is in the recent times it called as the 18 group, that contains the noble gases. Noble gases are not classified as the metals, non-metals or metalloids. They are just the inert group of the elements present in the periodic table. And these lanthanides, they are also called as the rare earths because they are very rarely present in the on the earth crust. So that was an overview of the periodic table, how many periods, how many groups are there, what is meant by the period number, what is meant by the group number. And most of the elements, they are metals. What is the location of metals? That is extreme right, middle and bottom. What is the location of the non-metals in periodic table? That is the extreme right. And the noble gases are not included. Now, there are these elements, lanthanides and actinides, they are total 28 elements. They are F block elements because the F subshell of their valence shell, that is under the process of completion when we look at their electronic configuration. Similarly, hydrogen and helium, they are called as the S block. Then this one, they are all P block elements. So on the basis of the electronic configuration, the periodic table is divided into 4 blocks, S, P, D, F, depending upon the type of the subshell which is under the process of completion in an element. Similarly, there are metals, non-metals, metalloids in the periodic table. Our next lecture will be about the detailed discussion of the blocks in the periodic table and that of the concept of the metals, non-metals and metalloids in the periodic table. Till then, take care.